Good evening, my YouTube viewers. It's Crystal here. I'm here because I want to do another code review. And what we're going to do in this code review is we're going to do a chi-squared test. And we're going to be talking about discrete distribution matching in this chi-squared test. So before we carry on with the code review, I thought it would be a good idea to actually find out exactly what a chi-squared test is. So we're looking on Wikipedia. In Wikipedia it says a chi-squared test, also called chi-square or x-squared test, is a statistical hypothesis test that is valid to perform when the test statistic is chi-squared distributed under the null hypothesis, specifically Pearson's chi-squared test and variants thereof. Pearson's chi-squared test is used to determine whether there is a statistically significant difference between the expected frequencies and the observed frequencies in one or more categories of a contingency table. In the standard applications of this test, the observations are classified into mutually exclusive classes. If the null hypothesis that there are no differences between the classes in the population is true, the test statistic computed from the observations follows x-squared frequency distribution. The purpose of the test is to evaluate how likely the observed frequencies would be assuming the null hypothesis is true. Test statistics that follow a x-squared distribution occur when the observations are independent. There are also x-squared tests for testing the null hypothesis of independence of a pair of random variables based on observations of the pairs. Chi-square test often refers to tests for which the distribution of the test statistic approaches the x-squared distribution asymptotically, meaning that the sampling distribution, if the null hypothesis is true of the test statistic, approximates a chi-square distribution more and more closely as sample sizes increase. So that was a lot to take in, but we had to talk a little bit about the chi-square test to do our code review. And I've got these questions. I'll show you where I got the questions. I got the questions from this video here. Statistics and Probability Full Course. That's where I got the questions. And then I got the answers in R. So I've got the answers in R and I translated them into Python. So that's basically what we have done. So I've got the first question is, I would like to test if my three-sided die is fair. To do this, I roll the die n equals 600 times and tabulate the observed frequency distribution. In the rolls, I get n1 equals 180, n2 equals 215, and n3 equals 205. So we're only going to use this right here to calculate it. So we're going to do chi-q.test x equals c brackets 180, 215, 205. Those were your observations. P equals c, 1/3, 1/3, 1/3. And those are your expectations. Those are your expectations. So they say that the p-value of 0.1969 is larger than the alpha of 0.05, so the assumption is accepted. So that means that the three-sided die is fair. And here you go right here. So you get a p-value of 1969. So we come over here and we've got exactly the same question, but we're using scipy.stats. And so we're going to be using stats.chi-square we're going to plug in the same values, and we're going to get a p-value of 1969. The next question. A friend claims the proportion of cars from Knox campus that are American are the same as the proportion that are from Europe and Asia. To test this, I went to the parking lot across from Berrien from SMC and counted the cars and their origins. There were 19 American, 23 Asian, and 2 European. So what we're going to do is we're just going to use this one right here, the CHICE-Q.test, and x equals c 19, 23, 2, and it gives you a p-value of 0.0002, and then since the p-value of 0.0002 is smaller than the alpha of 0.05, so the assumption is not accepted. And so the assumption was that the proportion of American cars are the same, and the null hypothesis is rejected. So we come over here to Python, got the exact same question, and what we do is we do stats.chi-square, and you plug in the figures, and then so it's 44 divided by 3, so the expectation is 44 divided by 3 and the 3 times, and you get a .0002, so that means that the assumption is not accepted. So the next one we're going to do is the math department claims the proportion of its graduates who went to the graduate school is twice the proportion of any other post-baccalaureate path. To test this, the math department sent out questionnaires to all of the alumni they had current addresses for. So your observations was 13, 7, 10, 5. The expectations were 14, 7, 7, 7. And so what we do is we plug that in to the CHICE-Q.test, and you got a p-value of 0.5874. So since the p-value of 0.5874 is larger than the alpha of 0.05, the assumption is accepted. And then so we've got the exact same question here, and all we do is we just put in the information. You just plug in the information, and you get your p-value of 5874 or 5873635. So that's close to 5874. So the next one, the last question, is a little bit more difficult to work with, but I'll go ahead and go over it with you anyway. One initiative of Knox College is to be more representative of the U.S. population. This raises the question whether the college has succeeded in terms of numbers. And so we just use this one, CHICE-Q.test, and then so I didn't write down the observations and the expectations, but I've got it in another written down on a sheet of paper because it was getting a bit late, or I was short of time. But the observations were 109, 73, 214, 635, and the expectations were 165.68, 73.1, 238.37, and 0.61, but they didn't use those in there. They used percentages, and then not only that, they rescaled the percentages. And so that gave you a p-value of 2.895 e to the negative 0.07. So since the p-value is less than 0.05, this indicates the college is not representative of demographics. But we come over here and we plug it in, and the chi-square, this NumPy stats, the SciPy stats chi-square test doesn't accept percentages. And then in addition to that, the observations has to sum. The sum of the observations has to be a sum of the expectations. So not only did it have percentages, it didn't sum up, and it didn't work. And the only way that I could get it to work was I summed up the observations, which was 1,031, and then I summed up the expectations, which was 1,032.76. So the expectations was 1.76 more than the observations. So the only way that I could get it to work was to subtract 1.76 from one of the observations. And so what I decided to do was I decided to subtract that number from the largest expectation. And so that's what I did, and that's how I got it to work. And so the p-value that I got is different from the p-value in R, because it's 2.895 e to the negative 7, and this was 2.213 e to the negative 7. But it's still a very minuscule amount. But I had to do that to get it to work, because SciPy Stats doesn't work the same way that R works. So I'm not going to put this question in my blog post anyway. So what I'm going to do is I'm going to go ahead and close this video because I've talked about all 4 questions. We've used the stats chi-square function, and we've used the R's chi-q.test function. And so we've covered this chi-square in both Python and R. So I've covered a lot of information in a short period of time. So I'm going to go ahead and conclude this video. If you like my video, please like, subscribe, and share. I would like to thank all of my subscribers for supporting my channel. And thank you so much for watching my code review. I look forward to making more code reviews for you in the future.